String handling in Java rough overview. Welcome to your complete guide on string handling in Java. In this session, we will explore one of the most important and frequently used concepts in Java programming, the string class and its related utilities. Whether you are working on backend systems, data processing, or simple user input validation, understanding how to use strings efficiently is critical. Java provides a rich set of tools and classes for string manipulation, from basic methods like substring and concat to more advanced concepts like immutability, more efficient string pooling, and thread safe alternatives like StringBuffer. By the end of this video, you will not only know how strings work but also how to use them smartly, avoid common pitfalls, and make your Java programs more readable, efficient, and professional. Agenda. Before we start, here quick overview of what we will be covering in this video on Java string handling. We will begin with an introduction to strings, what they are, how they are created in Java, and why they are special. Then we will explore the string class and the wide variety of methods it offers. Next, we will deep into string buffer and string builder, two powerful classes for working with mutable strings. You will learn their differences, advantages, and when to use which. After that, we will discuss string immutability, one of the most important concepts in Java strings that has performance and memory implementations. We will also walk through string comparison and manipulation methods, how to properly compare strings, split them, trim white space, replace content, and so on. Finally, we will wrap it all up with best practices and a summary to help you apply what you have learned in your real coding projects and interviews. Introduction to strings. In Java, a string is much more than just a group of characters. It is an object from the java.language.string class and is used in almost every Java programming. A string in Java is defined as a sequence of characters. For example, the word hello is a string, but what makes Java strings unique is that they are immutable, which means once a string is created, it cannot be changed. If you are trying to modify a string, say by adding characters or changing its case, Java actually creates a new string object behind the scenes. This behavior helps improve security, performance, and memory management in applications. The immutability of strings also makes them thread safe and suitable for constant values like configuration keys, usernames, or database queries. Because strings are so essential, Java optimizes their usage using something called a string pool, which we will talk about soon. So, whenever you use a string literal in your code, like hello, Java stores it in a special area of memory called the string pool, avoiding duplicate storage. Understanding how strings work at a basic level is the first step toward mastering Java programming. Strings. Now let's look at how you can create strings in Java. There are two main ways. First one, string literal. You can directly assign a string using double quotes like this. String s1 equals to hello with double quotes. This is the most common and efficient way. The JVM stores those in the string pool, which helps reduce memory usage by reusing identical string literals. Second one, using the new keyword. You can also create a string using new keyword. This creates a new object in memory even if the content is the same as an existing string. So it want to reuse the one in the string pool unless explicitly intended. Why does this matter? Because comparing s1 and s2 using equals to will return false. They are two different objects, but s1 dot equals s2 will return true since their content is the same. In real world coding, always prefer using string literals unless you have a specific reason to use new. Understanding this difference helps you write better code, especially when comparing strings or optimizing memory. String immutability. One of the most important concepts in Java string handling is immutability. Immutability means that once a string is created, its values cannot be changed. Any operation that seems to modify the string, like concat, replace, or substring, actually creates and returns a new string object. Why is this a good thing? Thread safety. Since the string value cannot change, you don't need to worry about it being altered by another thread. Hash code stability. Immutable objects don't change, so their hash codes remain stable. That's why strings work perfectly as keys in hash maps. Security. Immutability helps protect data, especially when strings are used for sensitive values like file paths or network addresses. So, next time you see strings, remember every change creates a brand new string behind the scenes. String pool. Let's talk about one of the most fascinating memory optimization features in Java, the string pool. Whenever you create a string using a literal, Java checks a special area in memory called the string pool. If that exact string already exists, it simply reuses the reference instead of creating a new object. This technique is known as string interning and it helps save memory, especially when many identical strings are used. However, if you use new string, a new object is created in the heap memory and it's not added to the pool unless you explicitly call intern. This brings us to a common mistake comparing strings using equals. Checks whether two references point to the same object in memory. Common string methods. Java string class comes with a wide range of built-in methods that make working with the text much easier. Some of the most frequently used methods include length, returns the number of characters in the string. Char at returns the character at the specified index. Substring extracts a portion of the string between two indices. Concat join two strings into one. Two uppercase and two lowercase. Change the case of characters. Equals and compare it to. For comparing two strings, removes leading and trailing spaces. Replaces characters or substrings. Split splits a string based on a given delimiter. Those methods help you clean, search, transform, and manage string data effectively. You will use those strings methods in almost every Java application, whether you are validating input, formatting output, or manipulating data. Get familiar with them and will boost both your productivity and your confidence. Length and caret. Let's zoom in on two simple but essential methods, length and caret. First one, length. This method returns the total number of characters in a string including spaces and special characters. Next, caret. This method gives you the character located at a specific index where indexing started from 0. Those two methods are the backbone of string navigation. For instance, if you want to reverse a string, count vowels, or find a particular character, you will definitely use length and caret. Be careful if you pass an index that's out of bounds, like carry at 100 for a 7-letter string. Java will throw a string index out of bounds exception. Understanding those basics lays the groundwork for more advanced string operations, including iteration, search, and pattern checking. Substring method. One of the most powerful tools in string manipulation is the substring method. It lets you extract parts of a string, like cutting a slice from a cake. There are two main forms of substring. First one substring start index. Second one substring start index, comma end index. The first version extracts from the start index to the end of the string, while the second extracts from start index up into but not including the end index. This method is extremely useful for tasks like extracting file extensions, parsing usernames from emails, slicing words. Just be careful with the indexes. Providing an invalid range will result is an exception. Using substring wisely can make your code cleaner and reduce the need for loops and manual character by character handling. Each one of those small methods that packs a big punch. Concat method. Next up is the concat method, a simple but useful function for joining strings together. But here's something important. Instead of concat, Java developers often prefer the plus operator. Both achieve the same result, but the Less operator is more readable and sometimes optimized by the compiler. However, in performance critical applications, especially inside loops, repeatedly using concat or plus on immutable strings can be inefficient because a new string is created every time. In such cases, you should be use string builder instead, which we'll discuss later. So to sum up, use concat or plus when dealing with a few strings. Use string builder for bulk or repetitive concatenation tasks. Understanding how to join strings efficiently is essential in building fast and readable Java applications. Equals and equals operator. One of the most common sources of confusion in Java is the difference between the equals method and the equals operator when comparing strings. Let's clear this up once and for all. The equals operator checks if two references point to the same memory location. The equals method checks if two strings have the same sequences of characters, their actual content. When you are checking string content, always use equals, especially when you get input from users database or files. If you mistakenly use equals operator, you may get unpredictability results and bugs that are hard to trace, especially in real-time applications where strings are dynamically created. This way, even if user input is null, your code won't to crash. Understanding these differences is a must for writing reliable, bug-free Java programs. Comparative method. To comparative method is used to compare two strings lexicography, that means alphabet by alphabet, using Unicode values. Its return values are 0 if the strings are equal, a negative number if the second string is greater. This method is commonly used in sorting, especially when you are organizing strings in alphabetically order. Let's say you want to sort a list of names. What's actually happening behind the scenes is a bunch of pairwise comparative checks to determine the correct order. Apple.comparative gives a positive values because lowercase characters have higher Unicode values than uppercase ones. To avoid that, you can convert both strings to lowercase before comparing. So, if you are working with alphabetical sorting, searching, or building dictionaries, compare it to if your best friend. Two uppercase and two lowercase. Those two methods, two uppercase and two lowercase, are super useful when you want to standardize text. Two uppercase converts all characters to uppercase. Two lowercase converts them all to lowercase. Why is this useful? Let's say you are checking user input. A better way. This makes your code more flexible and user friendly. Another common case is sorting strings in a case insensitive way. You can convert all strings to one case before comparison. This ensures consistent behavior regardless of how users enter text. So whether you are building a login form, a chatbot or a search filter, make sure to normalize your strings using those methods. Trim and replace. Those two methods, trim and replace, are greater tools for cleaning and modifying string content. Let's start with the trim. It removes any leading or trailing white space from the string. It's perfect for handling user input from forms where people accidentally add spaces. Now replace. It replaces characters or substrings with new ones. You can even use replace all if you want to replace based on regular expressions. Why are those useful? Trim is essential for validating form input. Replace helps in formatting strings like changing data formats or replacing bad words. Those functions are small but powerful, and when used correctly, they can save you hours of debugging string related issues. Split method. The split method is a powerful tool in Java for breaking a string into parts based on a delimiter. Let's say if you want to split by multiple delimiters, you can use a regex. This will split the text by commas, semicolons, or spaces. The split method is widely used for reading CSV files, tokenizing text, breaking down dates, names, or lists. Just to remember, if the delimiter is not found, it returns the original string as the only element in the array. Mastering split gives you full string builder class. Let's now explore the string builder class, your go-to tool when you need to modify strings repeatedly. Unlike the string class, which is immutable, string builder is mutable, meaning its content can be changed without creating a new object every time. This is much more memory efficient than repeatedly using plus operator or concat. So when should you use it? When building large strings in loops, when modifying strings multiple times. String builder comes with a range of helpful methods: append, insert, delete, reverse, and capacity. Always use string builder when performance is a concern and multi-threading is not required. We will look at string buffer next for thread safe use cases. String buffer class, just like string builder, the string buffer class is also used for mutable strings, but what sets it apart is that it's thread safe, meaning multiple threads can safely access it without causing data corruption. String buffer offers the same methods as the string builder: append, insert, delete, reverse, and more. So, when should you use string buffer? You are working in a multi-threaded environment. You need to ensure data consistency. You still want to performance of mutable strings. Avoid it when your code is a single threaded because the string builder is faster without the overhead of synchronization. Here a comparison. String immutable thread safe by nature. String builder mutable not thread safe fastest. String buffer mutable thread safe slightly slower than string builder. So use string buffer only when you actually need synchronization. Otherwise prefer string builder for better performance in most applications. Difference between string and string builder. Let's clearly break down the key differences between string and string builder because choosing the right one is crucial. Use string when the text does not change, like constant messages titles. You need to store a fixed value. Use string builder when you modify the string frequently. You are building strings dynamically, like generating HTML, logs, or loops. So, the big takeaway: use string builder for performance and string for safety and simplicity. Know the differences and choose wisely depending on your use case. Append, insert, delete. Let's explore some of the most commonly used methods of string builder and string buffer. Append, insert, and delete. Append method adds content at the end of the string. Insert method adds content at a specified index. Delete method removes characters from a specific range. Those methods make it easy to manipulate strings dynamically without creating new objects each time, which is what happens when you use the string class. You can change those methods for clean and readable code. Those operations are fast and efficient, and that's why string buffer is preferred in performance critical applications like compilers or real-time text editors. So if you are building or modifying strings dynamically, mastering those three methods will save you can ton of code effect. Reverse and capacity. Let's finish up this section with two underrated but powerful methods: reverse and capacity. Reverse method. This method reverses the characters in a string builder to string buffer. This is especially useful when you want to check for palindromes or display text backwards for fun effects. Capacity method. This method tells you how much memory space is allocated internally for the string. When you append content, the capacity expands automatically as needed. But to avoid multiple memory reallocations, you can set at an initial capacity. This is a great for performance tuning when you know the approximate size of the final string. Use ensure capacity if you are dealing with large data and want to control memory usage manually. Use reverse when needed for logic or presentation. Use capacity to optimize memory allocation when dealing with large or repetitive string operations. String formatting. Let's now talk about a very elegant feature in Java, string formatting using string.format method. This method allows you to create formatted strings using placeholders similar to what you may have seen in C with printf. This makes your output clean, readable, and easy to manage, especially when dealing with user facing content, reports, or logs. Why use string.format method over string concatenation? More control over layout, better readability, supports padding, alignment. So next time you need structured output, use string.format method for professional looking results. Values of method. The values of method in Java is a simple but very useful utility. It converts any primitive data types or object into a string. Let's say you have an integer. This works for all primitives: int, float, double, boolean, character. You can even pass objects. Why use values of method? It's safer than using toString directly because value of can handle nulls. Using toString on a null will throw a null pointer exception, but value of method just returns the string null, making your code more resilient. Another great use case is while printing variables or logging. Values of method is your safest tool to convert any data to a string form, essentially in debugging, file writing, and user messages. Regular expressions. Time to level up. Regular expressions or regex are powerful patterns used for searching, matching, and manipulating strings. Java supports regular expressions through the java.util.regularExpression package, primarily using two classes, pattern and matcher. You can do pattern matching, replacements, extracting data from text. Use regular expression when working with from validations like emails, phone numbers, passwords, searching features like filtering names or dates, cleaning messy text, removing symbols, white space. Here another example: split a sensitive by any non-word characters. Regular expression can look scary at first, but once you get the hang of it, you will realize it can replace entire blocks of code with a single smart pattern. So take the time to learn regular expression. It's a game changer for text processing in Java. Conclusion. And that's a wrap on your complete guide to string handling in Java. Let's quickly recap what we have learned. Java string is immutable, meaning every change creates a new object. String builder and string buffer are mutable. Use them when you need to modify strings as lot. Java offers dozens of built-in methods to manipulate, format, compare, and analyze strings. Use equals method for value comparison, not equals operator. For performance, use string builder in loops and large text constructions. Formatting with string.format method, converting use values of method, and parsing with the split method or regular expression make Java string handling powerful and flexible. And finally, always follow best practices: clean code, memory efficiency, and clear logic. Comment below if you have any questions or want me to explain any method in more depth. If you found this video helpful, don't forget to like, share, and subscribe for more Java tutorials. See you in the next one. Happy coding and keep building.